The last of our key concepts that we need to understand for our assignment and our assessment is doping, another thing that is beyond the realm of our level 2 chemistry core content. So doping is something that we do as a chemical process we do to something, to a polymer, to a plastic, so to a non-metal that will chemically add or remove electrons. And usually it's using something like a halogen gas, so something like bromine gas being added, or chlorine or iodine, something like that. And the reason for that is the effect that it has on our conjugated system with its pi bonds. So remember, our conjugated system is we've got single, double like that, where it's alternating. And because we understand pi bonds a little bit more now, we know that that basically means we've got the sigma bonds through the middle, through our carbon chain, and the pi bond electrons sort of above and below that, creating those double bonds. And those double bonds are able to shift or move and sort of initiate a chain reaction where this would keep going down the line. So, sorry, that first arrow is not overly good. It should go to the gap to create a double bond there. So we know that our conjugated system has got some pretty special characteristics about it, where it could allow for some sort of flow of electrons, but only the pi electrons. So by adding or removing electrons chemically, what we can do is we can slightly change the nature, the conductivity of this polymer. There are generally two types of doping that are done: reduction and oxidation. Now this is a concept we're not doing this year. We're going to explore oxidation reduction in year 13. Reduction is when you gain electrons or add electrons to something. So it seems a bit back to front, gaining is reduction, but it's to do with a thing called oxidation number that we'll look at next year. So when electrons are added to something or gained by it, we call that reduction. So how would reduction work on the effect of our pi bond electrons, the ones that are sort of shown by the green haze above and below? Well, if I have too many electrons in the molecule, in the polymer, then as soon as I put an electricity source here to provide even more electrons, they're really going to shift. Those extra electrons are in a different energy level. They're actually in different orbitals, but again, that's a level 3 concept. So they're at a different energy level to these electrons that are involved in bonding, and so they can more easily be transferred along the chain. So by adding electrons, using a reduction doping process, we make it really easy, as soon as we add just a little bit more electricity, for those to flow along and therefore conduct electricity. The opposite to that is oxidation. It's actually removing some electrons, and I think they sometimes call that N-doping. So I think reduction is often called pi doping because it sort of adds into the pi bond, it affects that. Oxidation is sometimes called N-doping. I believe it has an impact on the nucleus, or the relationship with the nucleus. That's not important. Oxidation is the opposite. It's when you lose electrons or remove them from the system. So why would that make it even easier or even better at conducting electricity? Well, if I remove electrons from this polymer, then what happens when I give some electrons is they very quickly go in. Then we go back to our original diagram where it shows that pi bonds can shift across. Well, as soon as we give a little bit of impetus to it, a little bit of push, then this sort of thing can start happening, this chain reaction with our pi bonds, and this flow of charged particles is indeed conductivity of electricity. So, to recap, doping is chemically adding or removing electrons. We normally do it with a halogen, so that's a group 17 element. What it does is it does a chemical process called reduction or oxidation, depending on which chemical it is used for the doping. Reduction is the gaining of electrons, which will basically overload these pi bonds so that any other electrical energy source will cause that movement to happen very easily. And oxidation is removing some electrons from this, which again means if I put a power source here, the attraction for the electrons from that power supply will be much higher, and then this conjugated system starts coming into play where we get that movement of pi electrons. Electrons are charged. Movement of a charged particle is electrical conduction. The analogy I would suggest you have in your mind is like when we rub a plastic ruler or a plastic rod, and that rubbing will either gain or remove electrons, will either add or remove electrons, and we create a static charge within that plastic rod. It's the same sort of idea here, only because this is chemically done, it doesn't disappear as soon as you earth it, so touch it to something else. That doping, that addition or subtraction of electrons stays there permanently.